This time, because you have 1 over x, you can't have x from 0. That's why it starts from 1. I have some vague idea of what the graph would look like, but let's not even go there. Okay? Let's just find the arc length just by using the formula. And if you use the Pythagorean principle and then divide by dx, multiply by dx, this is here, and because x is from 1 through 4, that's what you have to calculate. So let's try dy dx. Okay. What's dy dx? You're differentiating this. 3 comes down, so 3x squared over 12. And then 1 over x is like x to the negative 1 power. So negative comes out, and you get 1 over x squared. Let's reduce this. So we get 1/4 x squared minus 1 over x squared. Okay, but we still need the dy dx squared, right? So let's try what dy dx squared is. You have to square 1/4 x squared minus 1 over x squared squared. If you have two things subtracted, you have to do the first thing squared. Square of 1/4 is 1/16. X squared is x to the 4th. Square of this one is 1 over x to the 4th. Right? X squared squared is x to the 4th with a plus, because minus squared is plus. But there's something extra in the middle, right? Do you know what's in the middle? Something extra. Huh?
In the middle?
Yeah.
1/2?
No. Well, 1/2 will be eventually what you get, but yeah.
Is it just like the regular equation? Like the 1/4 x squared minus 1 over
No.
x squared?
No.
Well, you're multiplying x squared over 4 times 1 over x squared. So won't the x squared just cancel out and it'll just be 1/4 times 1/4? Or plus 1/4?
Eventually, that's what you get. Yeah. But what I'm trying to get at is, what's the formula for a minus b squared?
Oh, a squared minus ab
What's in between?
minus ab.
Minus, what did you say?
2ab.
2ab. Okay. I want every one of you to memorize this and make use of this. This will be very important, okay? So what we need is double the product in the middle, okay? There's an extra thing that's double the product in the middle. So it's minus twice of 1/4 x squared times 1 over x squared. And someone said 1/2, that's actually true. X squared cancels. 2 over 4 is just 1/2. Okay, then I can continue calculating this one. It's the integral from 1 through 4 of square root of 1 plus this thing here, 1 over 16 x squared minus 1/2 plus 1 over x to the 4th. All of this inside the square root dx. What's 1 minus 1/2?
Or 1/2.
Positive 1/2, right? Okay. So 1 over 16x squared plus 1/2 plus 1 over, no, something's wrong. This should be 4th power, so. Okay, so you have x to the fourth. Yes. Now, when you look at what's inside the square root, you notice that that looks very similar to this one. Isn't that right? This and this look very similar. And knowing that there's a version with the plus, what's the version with the plus? What do you get if you do
Just
this?
flip it.
A squared what?
Plus.
Plus.
Plus 2ab
Plus B.
plus b squared, right? So what I'm trying to get at is that this minus actually comes from this minus. If this becomes plus like this one, this is still a complete square. What is it? Square of what? It's something squared. What goes inside it?
Wait, why did we switch it to plus?
Did we switch it to 1/2? Positive 1/2? We didn't. How did this come about? Plus
Yeah,
1/2.
Oh, the plus one.
1 minus 1/2 gave you plus 1/2. We didn't flip it. It just became positive 1/2. All right, so what goes in here?
1 over 4x squared minus the.
No, this is plus, so you
Oh, plus 1 over
Plus.
x squared.
1 over x squared. Okay, so it becomes plus. And now the square and square root cancels. You have to integrate 1 through 4 of 1/4 x squared plus 1 over x squared dx. And now this integrates to 1 over 12 x to the third minus 1 over x, and you put 4 and 1. So you get 16 over 3 minus 1/4 minus 1 over 12 minus 1 over 1. So everything over 12 will give you 64 minus 3 minus 1 plus 12. So it'll be 72 over 12, which is 6. And this is so fickle. It's like very fragile. It's very fragile. Meaning that if I modify any one of these numbers, if I replace 1 by 2, suddenly your integral will be impossible to do. Okay? These are fine-tuned so that somehow in the middle you get negative 1/2, so that when you add them up, you get positive, and then it still becomes some complete square, which will cancel with the square root. If that doesn't happen, it's impossible for us to integrate. That's why the examples for the arc length are very few.